Now, in this session, we shall discuss certain results which we require in solving the word problems in the session of set theory. So now, let's start with what we know. So, I had discussed about disjoint sets in a Venn diagram. How do we represent disjoint set? This is set A and this is set B. Now, the first result, N of A union B, when A and B are disjoint sets, is given by N of A plus N of B. That is, the number of elements in A plus number of elements in B is equal to the number of elements in A union B. Okay, this happens when A and B are disjoint sets. Now, what if A and B are not disjoint sets? Suppose they are not disjoint sets, that means there is something in common. So here, this is how the figure comes. A union B when they are not disjoint. So, N of A union B, how will I write that? N of A, so that means this whole thing, plus N of B, that means this whole thing. So that this common portion I have taken it twice. While I was taking N of A, I took this portion. While I took N of B, I took this common portion. That means this common intersection point is taken twice. That means I need to subtract 1 of A intersection B. So N of A union B when they are not disjoint. This is when they are disjoint. When they are disjoint, which A and B are disjoint, then N of A union B is N of A plus N of B. But if they are not disjoint, that means there is something in common. That is, N of A union B is not, N of A intersection B is not a null set. Then I have, that means it is not disjoint. Disjoint means what? Their intersection will give you a null set. Now here it is not disjoint, then N of A union B is given by N of A plus N of B minus N of A intersection B. Okay. Now, what is N of A minus B? What do you mean by A minus B? The elements that belong to set A but doesn't belongs to set B, isn't it? I have already drawn the figure, Venn diagram for A minus B. Which is A minus B? Which belongs to A that doesn't belongs to B. This is A minus B. Now this is same as N of A. That means this whole section minus what? N of A intersection B. Right? Similarly, N of B minus A. What will it be? N of B minus N of A intersection B. Am I clear? Okay. Now, next we come to the result for 3 sets. 3 disjoint sets. That is A union B union C. What is N of A union B union C when the sets are disjoint? That is N of A plus N of B plus N of C. Okay, this is when the sets are disjoint, mutually disjoint. Okay, N of B there is nothing in common. In A union A intersection B there is nothing in common. B intersection C there is nothing in common. A intersection C there is nothing in common. That means they are mutually disjoint. When they are mutually disjoint, N of A union B is equal to N of A plus N of B plus N of C. Now suppose if these 3 sets are not disjoint, that is A union B union C. That is, they are not disjoint means what? They are not, their intersection gives you a null set. So they are not disjoint. Then N of A union B is what? N of A plus N of B plus N of C minus N of A intersection B minus N of A intersection C minus N of B intersection C plus N of A intersection B intersection C. Okay, so this is the formula for finding N of A union B union C. Am I clear? Now we move on to the problem session using Venn diagram. Now, when we discuss on word problems that we deal in the set theory, it is up to you whether you want to use the formulas to find or whether you want to use the Venn diagram to find. So I personally prefer that you draw the Venn diagram and from the Venn diagram you read the results needed. Okay, from the question, whatever that is asked from the Venn diagram, you can read it and write. So, in this next topic, next session, where we are going to discuss the problems, I'll show you both the ways of doing it. Okay, so now let's move on to the word problems. Now see this question, children. It is to write the roster form. The expression now given is in the set builder form. A is equal to set of all x such that x is an integer and minus 3 less than x less than 7. So here, what are the elements that comes here? The first question, A is equal to set minus 2, minus 1, 0, 1, 2, 3, 4, 5 and 6. So this is the expression of this in the roster form. Now coming to the second one, what is the set F? F is equal to set of the letters, set of all letters of the word better. Better, B, comma, E, comma, T, comma, R. As I have told you, E and T are repeating. One is enough. Okay. Next one, the third one. B is equal to set of. Now here, you are asked to check for x such that x square is equal to x for all x belonging to R. So, belonging to R. So, here x square is equal to x. I bring this x this side, x square minus x is equal to 0. So, x into x minus 1 is equal to 0. This implies x is equal to 0 and x is equal to 1. Okay, so this is the values of x satisfying this equation which belongs to a set of real numbers. So here what do you have? 0, 1. Am I clear? So these are the ways of it. So now this is how I represent the set in its roster form. Now let's come to the set builder form. Okay, so the first one, how will I write? Set 3, 6, 9 and 12. Okay, so I can write this A is equal to set of all x such that what is the what is 3, 6, 9, 12? These are the multiples, isn't it? So x is equal to 3n, where n belongs to where? Capital N. N belongs to, this is n. N belongs to capital N and the value of n is what? 1 less than or equal to n less than or equal to 4. Right? 1 less than or equal to n less than or equal to 4. Am I clear? So this is how I write the set builder form. Now we come to the second question. That is the second part. It is to write it in the set builder form. 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25. So how will I write set of all x such that x is equal to what? X is equal to n square, where n belongs to where? Set of natural numbers, and 1 less than or equal to n less than or equal to 5. So this is how I represent it in the set builder form. Am I clear? All of you? Okay. Now, let's see the next question. U is equal to set 1, 2, 3, 4, 5, 6, 7, 8, 10, 9 and A is equal to set 2, 4, 6, 8, B is equal to 2, 3, 5, 7. Verify A union B the whole complement is equal to A complement intersection B complement and A intersection B the whole complement equals A complement union B complement. Now what is this law called? It is the De Morgan's law. We had already discussed this. Okay. Now let's see the verification part of it. Now for that, what is A union B? That is the elements in A or elements in B. Whether the element must be in A or in B. So all the elements. So here 2, 3, 4, 5, 6, 7 and 8. These are the elements that comes in A union B. Now A union B the whole complement. That means the elements that is whatever the elements that you find in A union B, they are complement other than those elements, the rest of the elements from the universal set. Which are they? 1, 2, 3, 4, 5, 6, 7 are there here in this set. So I cannot take. So 1 and 9 are the elements in A union B the complement. Am I clear? Now, coming to the right hand side, A complement. Other than these elements, the rest of the elements from U. That is 1, 3, 5, 7, 9. That is A complement. Now, what is B complement? B complement is equal to 1, 2, 3 is here, 4, 5 is here, 6, 7 is here, 8 and 9. So, this is A complement and B complement. Now, A complement intersection B complement. What is that? That is both the elements which belongs to both A and B. A complement and B complement. No, sorry, not A and B. A complement and B complement. That is A complement intersection B complement. Which are those elements? 1 is common. Again, 3 is not there, 5 is not there, 7 is not there, 9 is there. Right? Now see this and this. Aren't they the same? A union B, the whole complement is equal to A complement intersection B complement. Am I clear? Can you do the second part? This verification part, A intersection B, the whole complement. Try doing it. Okay. Now I move on to the second part of the question. A minus B. What is meant by A minus B? The element that belongs to set A but is not there in set B. So which are they? Belongs to A but doesn't belongs to B. So 2 is there in B. 4 not in B. So 4. 6 not in B. So 6, 8. Okay. So these are the elements which belongs to A but doesn't belongs to B. 4, 6 and 8. Now what about B minus A? That means what? The elements which belongs to B but doesn't belongs to A. Belongs to B. 2 is there. 3 is not there in A. 5 and 7. These are the elements that comes in B minus A. Am I clear? Okay, children? Go through it. Now, let's see the next question. In a survey of 600 students, 150 students were found to be taking tea, 225 were taking coffee, 100 were taking both tea and coffee. Find how many were taking neither tea nor coffee. So we are asked to find now who are taking not tea and those who are not taking coffee. Both neither tea and coffee. So now N of T is what? We taking T is 150. N of T is 150. N of C is what? 225. What about N? What about 100? 100 were taking both tea and coffee. That is tea and coffee. T intersection C was 100. Now, in order to find how many were taking neither tea or coffee, I will find what is the total number of people who are taking coffee and tea. And from this value, I will deduct from 600 to give the number of people not taking tea and coffee. Am I clear? Okay. So, T union C is equal to N of T plus N of C minus N of T intersection C. So, N of T is what? 150 plus 225 minus 100. So, that is equal to 375 minus 100, which is equal to 275. Okay, so 275 people are taking coffee or tea, right? Now, we are asked to find the number of people who are taking neither tea nor coffee. So, number of people taking neither tea nor coffee. Okay, neither tea nor coffee means what? Neither tea, that is T union C, the complement. Okay, the complement of those who take. That is N of U minus N of T union C. Right? N of U means what? 600. Minus N of T union C means what? 275. Right? That gives you 325. Am I clear? Okay. Now see the next question. In a group of 70 people, 35 like orange and 52 like grapes. Each person like at least one of the two fruit. How many like both orange and grapes. Okay, so now here N of O is equal to 37, N of G is equal to 52. Okay, and it is also given N of O union G is equal to 70, because it is given each person like at least one of the two fruits. So nobody is exempted from this. So this is what I get. Now I know N of O union G is equal to what? N of O plus N of G minus N of O intersection G. How many like both orange and grape? This is what I need to find. Orange and grape. Okay. So NOG is what? 70 is equal to N of O union G. N of O union G is 70. N of O is 27. N of G is what? 52 minus N of O intersection G. So what is N of O intersection G? Gives you, say, 37 plus 52. That is 89 minus 70. Therefore, now, so that N of O intersection G is equal to 37 plus 52. What is that? 89. When 70 comes this side, minus 70. So what do you get? 19. So number of people, how many likes orange and grapes? Number of people who likes orange and grapes is equal to 19. Am I clear? Okay. Okay, let's move to the next question. Out of 100 students, 15 passed in English, 12 passed in Maths, 8 passed in Science, 6 in English and Maths, 7 in Maths and Science, 4 in English and Science, and 4 in all the three. Find how many passed in English and Maths but not in Science, Maths and Science but not in English, Maths only, more than one subject only. So looking at the question, you might feel that this is going to be a tougher job. But I will prove this by looking into the Venn diagram. So I draw the Venn diagram first. Okay. So this is the universal set U, and I have three sets, namely it is for English, Maths and Science, right? It is said that 4 in all the three. 4 passed on all the three. So the common intersection point will have 4 in it. Again, I am starting from the last. Okay. 4 in English and Science. So English and Science 4. See, the common intersection point of English and Science is what? This is the common intersection point of English and Science. Don't you have a 4 there? Yes. Next is 7 in Maths and Science. Maths and Science, you have 7. That means Math and Science, the intersection point is so much. Already you have a 4 there. When I write 3 here, Math and Science, you have 7 people there. Then 6 in English and Maths. 6 in English and Maths. Now see, English and Maths, this is the common intersection of English and Maths. Already 4 is there. I write 2 here. So English and Maths, now how many are there? 6 are there as it is given. 8 in Science. Science you have 8. Right? This is 4 plus 3, 7. How many is needed here? 4 plus 3, 7 plus 1, 8. So in Science, when you look into, there are 8 people here. Then 12 passed in Maths. Now Maths, you see, this is Maths, right? 4 plus 3, 7. 7 plus 2, 9. 9 plus 3 is 12, right? So if you look into Maths, there are 12 people. 4 plus 2, 6 plus 3, 9 plus 3, 12. So altogether Maths is 12 now. Now 15 in English. 4 plus 2, 6 already is there. 4 plus 2, English is so much. 4 plus 2, 6 is already there. Now how many more will come here? That is 9 will come here. So 4 plus 9 plus 4, 13. 13 plus 2 is 15. Am I clear? So now English and Maths but not in Science. English and Maths but not in Science. So the number is what? 2 people. Maths, because English and Maths but not Science. So this is the portion which is not including Science. How many are there? 2. Maths and Science but not English. Maths and Science but not English. So which is the common portion for Maths and Science? This is the portion. This is for all the 3. So here it is 3 here. Okay. Maths only for Maths. So that is Maths only. This is the portion, right? So Maths only, how many are there? 3 are there. More than one subject. More than one subject means 4 plus 2, 6 plus 3, 9 plus 3, 12. So that is more than one subject. Sorry. Okay. Now the next one is more than one subject. More than one subject means what? 2 plus 4 plus 3. 2 plus 4 plus 3. Okay. 4 plus 2 is 6 plus 3 is 9. One subject only. 9, 1 and 3. That is 9 plus 1 plus 3, which is 30. Am I clear? So it is very simple to find using Venn diagram. So you will draw the Venn diagram and start from the end of the question. Right? The first common indecision point. Then between 2 each. 2 each. Maths and Science. English and Maths. English and Science. And the rest will come where you will subtract. You will consider each of the sets. And then you will write the rest.